Hey you guys, this is Mr. Waltz. We're going to do circuit 11, which is the NPN transistor. So I'm going to make a copy, duplicate circuit 10 here. And we open this circuit up, and we're going to keep a few things. We're going to keep this switch. We're going to keep this 330 ohm resistor, and we'll keep one LED. Do not need the diode or the capacitor or these jumpers, so we get rid of those. We're going to go over here. We also need a NPN transistor, and you can see it's down there in the basic menu. It's got a big N on it, so we'll click that and drag it over. And this transistor, we're going to put this on the right side. It's in column J. We're going to put it in rows 3, 4, and 5. And we want to rotate it so the legs are facing to the left. And so 3, 4, and 5, row J. Okay, so the basic idea of this transistor is you put a positive circuit on C and a negative circuit on E. C is the collector, so current's going to come in and go in through the collector and then go out through the emitter. But it only can conduct when a signal is applied to the base B. So the base is like the control. So basically you wire everything you want to power up going through C and coming out of E. And then you put a positive voltage on B to turn it on or off, okay? So let's wire up our power part of our circuit first. So the thing we're going to power. So we're going to power this LED, this blue LED. So we're going to go up here to row 2, hook the 330 ohm resistor from positive to column A. And then we can take this LED, put it into row 2. So the anode is in row 2 and the cathode is in row 3. So now the positive signal's coming in through the rail, through the resistor, positive side of the LED. The negative side of this LED, we're going to connect this up to 3F over here. So when the transistor is turned on, it's going to allow current to come in from the power supply through the resistor, through the LED, across this jumper, into the collector. And then it needs to return back to negative. So the way we do that is just connect our emitter directly back to negative. And I'm going to make this top wire blue just in case I need to refer to it later. So I got a blue wire and a black wire. Okay, so that's the power circuit. And as long as the transistor is conducting, then this would light up the LED. However, right now there's no trigger applied here on the base. And so this transistor would just sit here and do nothing. So we have to figure out a way to apply a positive voltage. And so what I'm going to do is copy this resistor. And I'm going to put this down in row 8. I'm going to go from positive to 8A. And what we're going to do is we're going to make a really small current come through this resistor. So to make it a small current, we have to turn the resistance up. As you know, increased resistance makes the current smaller. And we're going to set this to K ohms. And what I found for this circuit is 22 K ohms. Works really well. So it's a really big resistor compared to what we've been doing. And as a result, it's going to have a really small current going through it. We're going to hook an LED on here. And the goal of this circuit is not to light up this LED. We're just putting this LED here as an indicator so that we know that we have current flowing in there on that part of the circuit. I'm going to make that one yellow, okay? So anyways, positive rail, 22 K ohm resistor to the anode of the LED, cathode of the LED. We're going to have that go into a switch. So I'm going to bring a switch down here. I'm going to put the bottom of the switch in row 9, top of the switch in row 7. And so the current will flow through the resistor, through the LED, into the bottom 2 legs of the switch. And then when we push the button, it engages the top 2 legs. And so we're going to run a jumper from the top 2 legs up to the base of the transistor that says B on it. And I'm going to make that one yellow because it comes from the yellow LED. So anyway, so here's the idea. So power comes on, right? You got positive voltage on your rail. When you hit this switch, it's going to allow current to flow in through the big resistor and the LED. And it's going to go in this yellow wire, and it's going to activate the base, all right? And this LED will come on. And then once that happens, the transistor can conduct. And so it's then basically acting like a switch. It turns on a connection between C and E internally. And so that lets current come in through the power supply, through the little resistor, blue LED, blue lead, into the collector, and then out through the emitter back to negative. And then that powers up that blue LED. So let's go ahead and try it out. Start the simulation. And you can see nothing happens. That's good. That means we did it right. You hit the switch. As soon as you hit the switch, you can see that both LEDs turn on. And you'll notice that the one on the bottom is much dimmer. And the reason for that is that it has far less current. So we're using a very, very tiny current here to control this transistor and make this much higher current turn on. And so that's basically the power of transistors. They are electrically controlled switches, and you can use tiny signals like ones generated by a computer to control big and powerful things like lighting systems or motors or whatever.